Dear students, all are welcome to my 7th class on atomic structure. In my last class, I discussed the shapes of different orbitals, the shape of a s orbital, shape of p orbital, and shapes of the d orbitals. So, in the d orbitals, there are 5 d orbitals. Out of that, the 4 has one type of shape, and the dz square orbital has a different shape. After that, I discussed the energies of the orbitals. So, in one electron system, the energy of the orbital depends upon the principal quantum number n. If n is same, the energy of the orbitals are same. For example, the 1s, the 2s, 2p, 3s, 3p, 3d. The energy of 1s and different from 2s, because here there is the principal quantum number are different. Here 1, the principal quantum number, here the principal quantum number is 2. And 2s and 2p have the same energy, because they have the same principal quantum number. And 3s, 3p, 3d have the same energy, because all have the same principal quantum number. This is for the atoms or the ions having a single electron. Okay. After that, I discussed the energies of the orbitals having a multi-electron, the multi-electron atoms orbitals. So, here the energy of the orbital is depends upon the n principal quantum number n and azimuthal quantum number L. ಎರಡರ ಮೇಲೂ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ. ಸೊ how do you compare the energy of the energies of the orbitals? So, here the n plus L rule. Here the orbital having a higher n plus L value has higher energy. Between two orbitals, or the two orbitals having a same n plus L value, then the orbital having a lower value of n has a lower energy. These two rules you have to remember. This rules helps to compare the energy of the orbitals. But so, see, there we have discussed some of example. The 4 has lower energy compared to the 3D. 4s has lower energy compared to the 3D, even though this has a principal quantum number 4, this is principal quantum number is 3. So, after that, I discussed the 4f, 6p and 7s. So, these orbitals having a same n plus L value. In such a case, what we have to do? We have to look only the principal quantum number. In all these cases, 4 plus 3, 7, 6 plus 1, 7, 7 plus 0, 7, all have the same n plus L value. In this case, what you have to look? Only you have to look for the principal quantum number n. So, here the 4f has a lower energy compared to 6p, 6p has lower energy compared to the 7s. After that, I discussed the filling of atomic orbitals. There I discussed the 3 rules. One is up-bow principle. According to this principle, the electrons are enter into various atomic orbitals in the increasing order of their energy. The orbital with the lower energy is filled first. After that, once the lower energy orbital is filled, next electron is moved to the higher energy orbital. So, this is what the up-bow principle. After that, one more thing I discussed, the Pauli's exclusion principle. What it says, no 2 electron in atom can have the same set of all 4 quantum number. So, see, according to this rule, the orbital can accommodate only 2 electrons of opposite spin. So, after that, one more rule, Hund's rule of maximum multiplicity. So, this rule is applicable to a subshell having more than 1 orbitals. The p subshell has 3 orbitals and d subshell has 5 orbitals. Similarly, f subshell has 7 orbitals. See there this rule, which rule? The Hund's rule is applicable. So suppose you have a 3 p subshell, means these are called degenerated orbitals, means they have the equal energy. So here the electrons are enter into this various orbitals in a same subshell. First, how they are enter? First they are singly occupied. Once all the orbitals of the given subshell are singly occupied, after that the pairing takes place. So this is what the Hund's rule of maximum multiplicity. So here, by using this rule, you can find out the number of unpaired electron in a given subshell or given atoms. So this is also the number of unpaired electrons, also the important property. It decides the many properties of the element. So here you are able to calculate how many unpaired electron are there in the atoms. After that, with this knowledge, we shall move to the electronic configuration of atoms. Now, so what is electronic configuration? Electronic configuration andre ಏನು? The distribution of electrons into a various atomic orbitals. So ಎಲ್ಲ electron ಎಲ್ಲಿರ್ತದೆ? Atomic orbital ಅಲ್ಲಿ. So what is electronic configuration? The distribution of electrons into various atomic orbitals. To write the electronic configuration, we should know some basic knowledge about this, the rules we are studied. If you know the atomic number of the element, you can write the electronic configuration of any element easily. For that, what you have to know? You have to know these rules, and you have to know the atomic number of the element. So here, the electronic configuration is the very important. This decides the properties of the element. Why the metal is, some are, sodium is a metal because of its electronic configuration. Like the chlorine is a non-metal. Why that is? Because of its electronic configuration. So you are able to write the electronic configuration of the any elements. For that, here there are two different ways to express the electronic configuration. ನೀವು ಒಂದು electronic configuration ಬರಿಬೇಕು ಅಂದರೆ ಅದಕ್ಕೆ ಎರಡು ಡಿಫರೆಂಟ್ ಮೆಥಡ್ ಇದೆ. ಒಂದು notation ಮೆಥಡ್, notations. ಈ notation method, how do you write the electronic configuration? The S, P, D, A, B, C, like this. This S, P, D represent the subshell. The electron is present. A, B, C represent a number of electron in each subshell. See, that means the A can be 0 to 2. In some orbital, it may be empty. Then you have to write it as 0 to 2 because this S subshell has only one orbital. Maximum it can accommodate 2 electrons. And what is the value of B? The B may be 0 to 6. How many p orbital are there? 3 p orbitals. That means it can accommodate a maximum 6 according to the Pauli's exclusion principle. Similarly, what is the D? D is raised to C. What is the C? The C may be 0 to 10 because there is a 5 d orbitals are there. They can accommodate a 10 electron. See, one more method is orbital diagram. Orbital diagram. Here, you have to write the box. For the S orbital, one box, S orbital, only one orbital, and P orbital, you have to write the 3 box. It's a P orbital, 3 P subshell, sorry, it's a P subshell, 3 orbitals, and in D subshell, you have a 5 orbitals. So D. This is called orbital diagram. The second method is the better than this notation method because here it clearly defines all the 4 quantum number for a given electron. So by writing the orbital diagram, suppose I write the 1s1. What does it means? 1 is the principal quantum number. S means L is equal to 0. If L is equal to 0, M is equal to 0, and it has the plus half. Its spin state is plus half. See, all the properties, all the 4 quantum number are, you can come to know by the orbital diagram, electronic configuration. Okay, so we shall try both the notation and orbital diagram for some of the elements. So, how do you write the electronic configuration for hydrogen and helium? The n is equal to 1 means, what is this one? N is equal to 1 means it's a first principal quantum number. Here L has only one value, it's a 0. L has only one value 0. M is equal to ML is equal to 0. That means the first principal quantum number only ಒಂದೇ ಸಬ್ಶೆಲ್ ಇದೆ, ಅದು ಎಸ್ ಸಬ್ಶೆಲ್ಲು. ಅದರಲ್ಲಿ ಒಂದು ಆರ್ಬಿಟಲ್ ಇದೆ, ಅದಕ್ಕೇನಂತೆ ನಾವು 1s ಆರ್ಬಿಟಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇಟ್ಸ್ ಕಾಲ್ಡ್ 1s ಆರ್ಬಿಟಲ್. How many electron it can accommodate? Only the 2. Therefore, electronic configuration of hydrogen, it's atomic number 1. How do you write? So, in notation method, you have to write it's a 1s1, 1s1. And in orbital diagram method, you have to write it like this, 1s. After that, hydrogen, the second atomic number 2 is helium, a noble gas, helium. So, how many electrons are there? Atomic number is 2 means it has a 2 electron. It's a 1s2, or you can write the in orbital diagram like this. This is the electronic configuration of helium. Now, the lithium, the atomic number 3 is lithium. Now, this first principal quantum number is filled up. The atomic number of helium is 3 means the third is electron has to go for which principal quantum number? The principal quantum number 2. If n is equal to 2, L has a 2 values 0 and 1. L has a 0 means ML is equal to 0, and L is equal to 1 means ML is equal to -1, 0, +1. That means in second principal quantum number, how many orbitals are there? 1 s orbital, that we are calling as 2s because it's present in a second principal quantum number, and 3 p orbitals, these are called 2p orbitals. So, for the second principal quantum, how many electron can it accommodate? It can accommodate 8 electrons, 2 in a 2s orbital and 6 in a 2p orbitals. Okay, let us write the electronic configuration of the next 8 element. Lithium, next is the beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the 8 elements. What is its electronic configuration? In all the case, it's a 1s, it's a 2s, it's a 2p. Here, all these cases, the 1s is already filled up for all the elements. All this element, the first principal quantum number is already filled up. There is a 1, 2s and 3p orbitals like this. This is a 2p orbital. So, atomic number lithium is 3. 2 electrons are occupied in a first principal quantum number. The third electron goes to the 2s orbital. This is the electronic configuration of 1s2, 2s1. And beryllium, the next electron, its atomic number is 4. That means these 2 electrons enter into the 2s orbital. The 2p orbital is higher energy, therefore both the electron goes to the 2s orbital. Next, in boron, its atomic number is 5, means 1 electron is now enter into the 2p orbitals. The carbon atomic number is 6. You know that the Hund's law. Now the electron is not pairing take place. The electron is entered into the next p orbital. In nitrogen, atomic number 7. Here 1, 2, 3. And oxygen, atomic number 8. Now, how many electrons are present in a p orbital? 4. The first, they are singly occupied. Next, the fourth electron is paired up. And fluorine, the atomic number 9. 1, 2, 3. The whole 5 the p electron are present in this p orbital. The 2 are paired up. And neon, atomic number 10. Now all the electrons are now paired up. There is no unpaired electron. All the orbitals are at the in second principal quantum number. All the orbitals are paired up here. So this is the second principal quantum number. So in the first principal quantum number, there are 2 elements. In second principal quantum number, you are written for the 8 elements. So after that, now the next electron, where it has to go, n is equal to 3 means L has 3 values 0, 1, 2. Here ml is equal to what? ml is equal to 0, here minus 1, 0, plus 1, here minus 2, minus 1, 0, plus 1, plus 2. In third principal quantum number, you have how many orbitals? Totally you have 9 orbitals. Here, the atomic number, what? The 11 is a sodium. So now the electron has to go which orbital? N is equal to 3, L is equal to 0, ml is equal to 0 means 3s orbital. After that, N is equal to 3, L is equal to 1, that means you have 3p orbitals. And N is equal to 2, ml is equal to N is equal to 3, L is equal to 2 means it's a 3d orbital. But here the 3d orbital has higher energy than a 4s orbital. That means now the 2 electron goes to 3s orbital. After that, the 6 electron will go to the p orbitals. After that, which orbital will fill first? The 4s. After that, the 3d orbital will fill. So atomic number, the 11 to 18. Atomic number 11 to 18. Let's say the sodium, magnesium, aluminum, silicon. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. So here atomic number 11, 12, 13, 14, 15, 16, 17 and 18. Here the electronic configuration of this lithium and sodium is in outer electronic configuration is same. Here it's a 2s1, here it's a 3s1. Now look this one. This orbital is filled up. This is called the inner core electron. For sodium, the inner core contain a neon configuration. In sodium, the inner core has how many electrons? 10 electrons. That means a neon configuration. The valency shell is what? the 3s1. See, how do you write the electronic configuration of sodium? The neon configuration. What is that neon configuration? It has a 10 electron, its core is filled. Then what is electron? How do you write the electronic configuration of sodium? A neon and 3s1. After that, the magnesium. Magnesium is what? The neon configuration and 3s2. And aluminum, how do you write? Neon configuration and 3s3. Sorry, 3s2, 3p1. The 2 electron goes to the 3s orbital and one more electron will go to the 3p subshell. And silicon, it's a carbon family. Here neon configuration and 3s2, 3p2. And phosphorus neon configuration and 3s2, 3p3. Look, the electronic configuration of neon, it's a phosphorus, and nitrogen and phosphorus are same in valency shell. How many electrons are there? It has also 2 plus 3, it's also 2 plus 3. Sulfur electronic configuration is, the valency shell is what? Similar to the oxygen. Here neon configuration and 3s2, 3p4. And chlorine neon configuration and 3s2, 3p5. Argon, what is that one? Neon configuration and 3s2, 3p6. See, this neon has also 8 electron in the valency shell. Argon has also 8 electron in the valency shell. And fluorine has a 5 electron in the valency shell. And chlorine has a also, sorry, the fluorine has a how many electron in their valency shell? 7 electrons. And chlorine also 7 electrons in their valency shell. Which one is away? Here, this is the inner shell and this is called outer shell. Here also up to neon, up to this neon configuration, this is called inner shell. The outer shell is what? 3s1, 3s2, like that. Okay. That means you have written the electronic configuration up to atomic number 18. Now, the atomic number 19 and atomic number 20 are the potassium and calcium. Atomic number 19 means the potassium. Atomic number 20 means it's a calcium. See, atomic number 20 is calcium. Atomic number 19 is potassium. So here the atomic number and element and its electronic configuration. I will write this side. Here the atomic number, its symbol and electronic configuration. See, atomic number 19, its symbol is K. Now, how do you write its electronic configuration? Argon, argon is what? 18. Argon configuration for potassium, organic configuration, it's a 4s1. In a sodium, it's a 3s1, and potassium, it's a 4s1. Here, neon configuration, 3s1. Here, argon configuration and 4s1. In calcium, argon configuration, a 4s2. It's similar to the magnesium. Okay. After that, it's 19. The next 10 electron goes to the 3D subshell. So before that, I want to discuss the one more concept here. What is that one? The stability of half-filled and completely filled orbitals. So, you have studied up to atomic number, how to write the electronic configuration of the elements up to atomic number at 20. Now, the stability of completely filled and half-filled atomic orbitals. completely filled and half filled atomic orbitals. Here, what is the meaning of completely filled and half filled atomic orbitals? You know that in a p subshell you have a 3 orbitals. Suppose each orbitals is occupied by 1 electron on each, then it is called half filled atomic orbital. P3, the P3 configuration is called half filled atomic orbital. If all the orbitals, all the p orbital means all 3 p orbital are occupied by 2 electron each, that means a p6 configuration is called a completely filled orbital. In d subshell also, how many orbitals are there? You have a 5 orbitals. So if all are occupied by a single electron, then it is called half filled d5. Similarly, a d10 is called a completely filled configuration. If any element having a d10 configuration, what you are saying that it's a completely filled d orbitals. If 5 electron it is having, then you are calling it's a half filled atomic orbital. Similarly, there are 7 f orbitals, that means f7 configuration is called half filled, f14 configuration is called completely filled. Now, these configuration have extra stability. Stability means they have the lower energy, because of that the stability is more. Why it is so? So why it is so? Because there are 2 reasons, mainly 2 reasons. They have the more stability. One is a symmetry. So here symmetry of you look the p orbital, all have the single electron. This means it is a symmetry. Because of symmetry, in a science wherever the symmetry comes, means they have the lower energy and stability is increases. So this is because of symmetry, the energy of the orbital is decreases. Second one is the exchange energy. Exchange energy. What is this exchange energy? We shall discuss this exchange energy by taking a d5 configuration. Here, the d5 means each orbital has a single electron, d5 configuration. One like this. Here, now the given subshell, if each orbital having a single electron, or in each orbital the electrons can exchange their position if they have the same electron spin. So this shows all these electrons have the same spin, they can exchange their position. So here this electron can exchange how many position it can exchange? It can come to here, or it may goes to here, or it may goes to here, or it may goes to here. That means this electron has a 4 exchange. And the second electron, it has a 3 exchange, 1, 2 and 3. And this electron has a 2 exchange, this electron has a 1 exchange. First electron 4, second 3, 2 and 1. Totally you have a 10 exchange if it has a d5 configuration. So because of this exchange in position, their stability is increases, their energy is decreases, stability is decreases. This is called the exchange energy. ಏನಾಗ್ತದೆ, ಇವು ಪೊಸಿಷನ್ ಅನ್ನು ಎಕ್ಸ್ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಒಂದು ಇಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ ಅಂದರೆ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ. ಬಿಕಾಸ್ ಆಫ್ ದಟ್, ಬಿಕಾಸ್ ಆಫ್ ಎಕ್ಸ್ಚೇಂಜ್ ದ repulsion between the electron is decreases. The electron are like charges. There is a Colombian repulsion. Because of that, exchange their position, their energy is decreases. One more is, you know that the d electrons have a poor shielding effect. The s electrons have a very strong shielding effect. Why? Because s electron, s orbital is spherical in shape. The electrons are spend more time, s electrons are spend more time near the nucleus. Because of that, they have a strong shielding effect. These s electrons are not allowed the valence electron to attract strongly by the nucleus. So, but these electrons have a poor shielding effect. Increasing the electron in the d orbital not increases the shielding effect. Because of that, these electrons are strongly attracted by a nucleus. If electrons are strongly attracted by nucleus, means its energy is decreases. ಏನಾಗ್ತದೆ ಎಸ್ ಇಲೆಕ್ಟ್ರಾನ್ ನೋಡಿ ಇಲ್ಲಿ ಡಿ ಇಲೆಕ್ಟ್ರಾನು ಜಾಸ್ತಿ ಆಗೋದ್ರಿಂದ ಏನಾಗ್ತದೆ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟು ಜಾಸ್ತಿ ಆಗೋದಿಲ್ಲ. ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟು ಜಾಸ್ತಿ ಆಗೋದಿಲ್ಲ ಅಂದರೆ ನೀವು ಅಟಾಮಿಕ್ ನಂಬರನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ತೇ ಹೋದ ಹಾಗೆ ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸು ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಆ್ಯಂಡ್ ದಿಸ್ ವೆಲೆನ್ಸಿ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಅಟ್ರಾಕ್ಟೆಡ್ ಸ್ಟ್ರಾಂಗ್ಲಿ ಬೈ ದ ನ್ಯೂಕ್ಲಿಯಸ್. ನ್ಯೂಕ್ಲಿಯಸ್ನಿಂದ ಅಟ್ರಾಕ್ಟ್ ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ದ ಸ್ಟೆಬಿಲಿಟಿ ಈಸ್ ಇನ್ಕ್ರೀಸಸ್. ಸೊ ದೀಸ್ ಆರ್ ದಿ ರೀಸನ್ for the stability of half-filled and a completely filled orbitals. So, what is that one? The 3p3, p3 configuration, p6 configuration, or d5 configuration, or d10 configuration, or f7 configuration and f14 configuration are more stable than other electronic configuration. One thing is it because they have the symmetry, one reason. Second one is they can exchange their position. Which electron exchange their position? The electron in the same subshell, means they have the same energy. And if they have a same electron spin state, either like this, or the electron having a same spin state, they can exchange their position. So this is the reason their energy is decreases because of exchange their position. Okay, so now we look the electronic configuration of atomic number the 21 to 30. The 21 to 30 are called, what they are called, the d block elements, because the electron enter into the 3d orbitals. Now you look the element atomic number electronic configuration. So the scandium 21, its atomic number is 21. What is the electronic configuration? Already you know the electronic configuration of calcium. Argon, it's 18 electron are in the inner core, argon. After that you have a 4s2, and now the electron is entered into the 3d orbital, inner 3d orbital. The outer 4s orbital has the 2 electron already occupied. Now the electron comes to the inner 3d orbital. After that, the scandium titanium, it's a 22. Its atomic number, what is its configuration? 3d2 4s2. Titanium vanadium 23. Argon configuration 3d3 4s2. Chromium 24. See, what is the electronic configuration you are expected here? Argon configuration 3d4 4s2. This is the configuration you are expected, but this is not. So already I discussed the one thing, the extra stability of half-filled atomic orbital. So because here the chromium has electronic configuration 24, means what is expected here? Argon. Here now one of this s electron is shifted to 3d orbital. The energy difference between the 4s and 3d is very small. Therefore, in order to gain the stability, the one of the 4s electron is shifted to electron. This is the configuration for the atomic number at 25 chromium. All you have to remember. This is against the above principle. So above principle ಏನು ಹೇಳುತ್ತೆ, lower energy orbital first fill up ಆದಮೇಲೆ electron is moved to the higher energy orbital. But for the extra stability, the 4s electron is shifted to a 3d orbitals. Therefore, the configuration is what? It's a 3d5 and 4s1. This you have to remember. Electronic configuration of, write the electronic configuration of chromium with atomic number 24. So, after that the chromium manganese, it's atomic number 25. See the argon configuration. Now the electron is moves to which orbital? 4s2. It is also retains the half-filled electronic configuration. After that, the iron 26, it's a argon configuration. It's a 3d6 4s2. 27 is a cobalt. It's 27 argon configuration, and 3d7 4s2, and cobalt nickel 28 argon configuration and 3d8 4s2. Now the 29 is copper. Now look the electronic configuration of copper. I write this side. Element is what? A copper, atomic number 29. Electronic configuration is argon. So what is this nickel? 3d8 4s2. Here what is the expected configuration? 3d9 4s2, but now it's a 3d10 4s1. Here also one of the s electron is shifted to a little bit higher energy d orbital in order to attain a completely filled configuration. You know, d10 configuration is a completely filled orbital. So here to gain the extra stability, one s electron is shifted to 3d orbital. So this configuration also you have to remember. It's a point of examination. Both are important. So usually you have a question like this, write the electronic configuration of chromium with atomic number 24, copper with a 29. See what you have to remember, this s electron is shifted to 3d orbital. After that, last one is in a 3d series, last element is a zinc. So atomic number is 30. Its configuration is what? Argon configuration, a 3d10 a 4s2. So 30. Once the 3d orbital is filled, the next orbital is a 4p orbital. See how many electron it can accommodate? The 6 electron. What are these elements? Next is the element atomic number electronic configuration. Element is the gallium, atomic number 31, germanium 32, after that arsenic 33, selenium 34, bromine 35, krypton 36. So here what is the electronic configuration? The argon configuration and 3d10 4s2 3d10 and 4s2 4p1. Like that is a argon configuration 3d10 a 4s2 4p2, argon configuration 3d10 a 4s2 4p3, argon configuration 3d10 a 4s2 4p4, argon configuration 3d10 a 4s2 a 4p5, and for krypton argon configuration 3d10 a 4s2 a 4p6. So say atomic number 36, it's a noble gas. So you can write the electronic configuration of the other elements also. At least you have to remember atomic number up to 36. Okay. See after that. Okay students, this is your the second chapter, atomic structure. So, for your level, some of the concepts are little bit difficult. See, ಪುಸ್ತಕದಲ್ಲಿಯೂ ಜಾಸ್ತಿ ಬರೆದಿದ್ದಾರೆ. You cannot understand the directly the some of the concept whatever written in a textbook. Anyway, you try to listen the class 2 or 3 times. Definitely, you can understand the at least some of the concept. Okay. So, I will quickly recap the what you are studied in this chapter, what you have to remember for the point of examination. So, in my first class, I discussed the whatever subatomic particles, discovery of subatomic particles, electron, protons, and neutrons. After that, their properties, what is the mass, their charges and all. So, after that, the Thomson's model, the Rutherford model, alpha ray scattering experiment. After that, Rutherford model. The reason for this failure of this model, this I discussed in the first class. The second class, I discussed the dual behavior of electromagnetic radiation. The electromagnetic radiation is a wave character. They have the lambda and they have the frequency. See, these are I discussed in the wave nature of the light. So, there you have to remember the what is the equation relation between lambda and mu. The C is equal to mu lambda. This relation you have to remember. You know the wavelength, you can calculate the frequency. See, after that, the particle nature of the light. I discussed the particle nature, there the black body radiation. So, there I discussed the Planck's theory. According to Planck's, the energy emitted or absorbed in the form of a discrete quantity. This is called a photon. This explains the electromagnetic radiation is a particle nature, because there is no, it's not a continuous manner. The atom or molecule absorbs or emits the radiation not in continuous manner, means it's a discontinuous. Wave means it's a continuous nature. The particle nature we are defined. So, here if you know the frequency, you can calculate the energy of the photon. Energy of the photon ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಬರಬೇಕು. ನಿಮಗೆ ಏನು ಬೇಕು, ಅದಕ್ಕೆ ಒಂದೇ ಫ್ರೀಕ್ವೆನ್ಸಿ ಗೊತ್ತಿರಬೇಕು ಅಥವಾ ವೇವ್ ಲೆಂತ್ ಗೊತ್ತಿರಬೇಕು. So, these are useful for the calculation of what the energy emitted. After that, the photoelectric effect. There we have discussed the Einstein explanation. H mu is equal to H mu naught plus half mv square. This is the energy of the incident photon. This is a energy work function used for the removing the electron, and the remaining energy is converted into a kinetic energy. Okay. After that, the thing we have discussed in the chapter is the Bohr's postulate. The point of examination, the postulates of Bohr theory are very important. There are a Bohr postulate. You are able to write, at least you are able to write this postulate. So, and after that, one more thing, the explanation of hydrogen spectra. See, here also sometime the problems are asking. See, what is this one? The energy delta E is equal to RH into 1 by n initial square minus 1 by n final square. You can calculate the energy easily. Suppose you know the RH value, 2.18 into 10 to the power of minus 18. So, suppose electron is moved from the first to second, that means first to second 1 minus 4, 3 by 4 of this RH value. So similarly, if is moved from second to first, minus 3 by 4 of this one. That's all. Only you have to take first you have to calculate this value. See, the electron ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಮೂವ್ ಆಯಿತು, 2ರಿಂದ 3ಕ್ಕೆ ಆಯಿತಾ, 3ರಿಂದ 4ಕ್ಕೆ ಆಯಿತಾ, 4ರಿಂದ 2ಕ್ಕೆ ಅಂತ. See, depending upon the N1 and N2. So ಯಾವಾಗ ಡೆಲ್ಟಾ ಇ ನೆಗೆಟಿವ್ ಆಗ್ತದೆ, electron, so the electron is come from higher energy level to lower energy level. ಆವಾಗ ಎನರ್ಜಿ is emitted. ಆವಾಗ ನಾವೇನಂತ ಬರಿತೀವಿ, ಡೆಲ್ಟಾ ಈಸ್ ಈಕ್ವಲ್ ಟು ನೆಗೆಟಿವ್ ಅಂತ ಬರಿತೀವಿ. ಓಕೆ, ಡೆಲ್ಟಾ ಇ ಪಾಸಿಟಿವ್ ಅಂದರೆ ಅರ್ಥ ಏನು, ಎನರ್ಜಿ is absorbed. Okay, if you know the delta E, you can calculate the frequency. Frequency is equal to delta E by H. If you know the frequency, you can calculate the lambda. Lambda is equal to C by nu. All this calculation you can do. You can easily solve a problem. Suppose problem is asked here, you are able to solve. What is the calculate the wavelength of the light emitted, or frequency of the light emitted, or the energy of the radiation emitted. See, this type of question suppose asked, you are able to calculate it. See, for that only thing you have to know this equation. So after that, the one more thing, limitation of Bohr's theory. There are 4 limitations. You are able to write the limitations of the Bohr's theory. Next is the quantum mechanics. There I discussed the quantum numbers. That is very important for the point of examination. The significance of 4 quantum number. The first 3 quantum number, one is they explain the size of the orbital, second one is shape of the orbital, third one is the orientation of the atomic orbital, the fourth one the spin state, orientation of the electron spin. These points you are able to, minimum you are able to write these points. After that, one more is the values of the N, L, ML and MS. For N is equal to 3, write the values of all the values of L and ML. N 3 ಇತ್ತಂದರೆ L ನ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿರ್ಬೋದು, 0, 1, 2. ಯಾವಾಗ L ನ ವ್ಯಾಲ್ಯೂ, M ನ ವ್ಯಾಲ್ಯೂ ಹೈಯೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿರ್ಬೋದು, it cannot be less 1 unit less than the value of N. N is equal to 3 ಅಂದರೆ L ನ ವ್ಯಾಲ್ಯೂ ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಷ್ಟಿರೋದು, ಸಿ 1 ಯೂನಿಟ್ ಲೆಸ್ ದೆನ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನ್. ಎಷ್ಟು ಮ್ಯಾಕ್ಸಿಮಮ್ 2 ಇರ್ಬೋದು, 0 ಮತ್ತು 1, 0, 1, 2. ಅವಾಗ ಎಲ್ 0 ಇತ್ತಂದರೆ ಎಮ್ ಎಲ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾಗ್ತದೆ, 0 ಆಗ್ತದೆ. ದಿಸ್ ಥಿಂಗ್ಸ್ ಯು ಆರ್ ಏಬಲ್ ಟು ರೈಟ್, ಬರೀಬೋದು ಈಸಿ. ಸೊ ಆಫ್ಟರ್ ದಟ್ the energy shape of the orbital, sometime sketch the shape of a dz square orbital or px orbital or s orbital. See, this you are able to write. After that, one more thing is the comparison of energy between the orbitals, n plus l rule. This is also very simple. Here n ಅಂದ್ರೇನು, ನೀವು ಒಂದು ನಂಬರ್ ಬರೆದಿರ್ತಲ್ಲ, that is called the n. This is n. 6p ಅಂತ ಬರೆದ್ರೆ n ಅಂದ್ರೇನು 6. For p orbital L is equal to 1. For suppose 6p ಅಂತ ಹೇಳಿದ್ರೆ n plus L ಎಷ್ಟಾಗ್ತದೆ, 7 ಆಗ್ತದೆ. ಸೊ 4d ಎಷ್ಟಾಗ್ತದೆ, n plus L ಎಷ್ಟಾಗ್ತದೆ, the 4 plus 2 is equal to 6. Therefore, the 6p has higher energy compared to the 3d. ಸೊ ಇದು ಎನರ್ಜಿ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡಲಿಕ್ಕೆ ಬರಬೇಕು ನಿಮಗೆ. ಯಾವುದಕ್ಕೆ ಕಡಿಮೆ ಎನರ್ಜಿ ಇದೆ, ಯಾವುದಕ್ಕೆ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಇದೆ ಅಂತ ಕೇಳಿದರೆ ಯು ಆರ್ ಏಬಲ್ ಟು ರೈಟ್ ದಿಸ್ ಕ್ವಶನ್. ಸಿ ಒನ್ ಮೋರ್ ಈಸ್ ದ 3 ರೂಲ್ಸ್ ಆಫ್ Bohr ಪ್ರಿನ್ಸಿಪಲ್, Hund's rule of maximum multiplicity ಆ್ಯಂಡ್ ಪೌಲಿಸ್ ಎಕ್ಸ್ಕ್ಲೂಷನ್ ಪ್ರಿನ್ಸಿಪಲ್. ಎಲ್ಲದಕ್ಕೂ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರಬೇಕು ನಿಮಗೆ. ಸಿ ಆಫ್ಟರ್ ದ್ಯಾಟ್ the electronic configuration. Here in electronic configuration, the most important is your electronic configuration of the chromium 24 and copper 29. ಎಲ್ಲ ಎಲಿಮೆಂಟಿಗೂ ಬರಬೇಕು at least. So these are the chromium 24 ಮತ್ತು ಕಾಪರ್ 29 ಯೂಸ್ವಲ್ ಪ್ಯಾಟರ್ನಲ್ಲಿಲ್ಲ. ಒನ್ ಆಫ್ ದ ಪೋರೆಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿ ಬಂದಿರುತ್ತೆ, 3D ಶೆಲ್ಲಿಗೆ ಬಂದಿರುತ್ತೆ, ಇನ್ ಆರ್ಡರ್ ಟು ಗೇನ್ ದ ಎಕ್ಸ್ಟ್ರಾ ಸ್ಟೆಬಿಲಿಟಿ. ಸೊ 3D pi and 3D10 copper only. So this thing you have to remember. Okay. So after that, okay. So this is your chapter. Listen the class one more time. Anyway, thank you.